Good morning, everyone. Thanks for coming. So today we are going to talk about giving capabilities to everyone to experience COD on demand. So that's the main theme. But before we get started, we'll quickly talk about what Flex is so that people have an idea of us as a company. So next slide, please. So we are a global organization. We are in around 190 countries. We have manufacturing footprint, which is spanning 52 million square feet. Just to give you a comparison, that's more than 1,000 football fields. So we do massive scale. And we also have design engineers who take part in activities on the open source front. So what is our relationship with CORD? We got involved in CORD very early on. First distribution, which was Creamy Vegetable, launched 18 months back in 2016. And then we started contributing resources internally to start experimenting with the stacks as they were coming alive. And today what we are doing is we are trying to make this resource available to broader community because we experienced certain pain points. And idea is we want others to have a much smoother journey as they go and experience CORD stack and how it can be used. So it's funny, there is a TIP conference going on just a couple of miles from here at Santa Clara Convention Center, and they are also talking about edge computing. So it's very interesting to view where CORD sits from perspective of edge computing. ITSI has a standard called multi-access edge computing. And what they have done is they started with mobile edge computing and they changed the name because they realized that edge is actually distributed. It occurs in many different locations and it serves many different customers. So if you go take a look at user equipment and customer premise, that's one edge, which is gateway, which is serving IoT devices, which could be in your homes. When you look at mobile edge computing, that's the radio access network, which is edge 2. And then CORD is edge 3, which is including both wireless through mCORD as well as fixed line access through residential CORD. And the way we define edge in a very simplistic fashion is you look at the subscribers basically, and you have certain point where you decide that if the number of subscribers which you are serving is less than certain point, then that's what you call edge. Because if you go into the core, then the subscribers can be served in millions. And obviously you have to define some demarcation point. So that's basically how we conceptually try to look at the edge. And people talk about telco cloud and data center cloud. The way we view telco cloud is a distributed nature of edge, which provides all different services and it's run by operators. That's basically where all the computing is migrating with 5G and new services appearing. And that's what is going to be the telco cloud. Data center cloud is what you have your traditional understanding of hyperscalers building at scale, providing IT workloads from the core. Next slide, please. I won't go too deep because all of you are very familiar, but the idea is CORD is building momentum. There are multiple POCs, multiple companies taking part in it. However, there's a certain point where people are experiencing friction in deploying CORD, and we ourselves went through it. So what do we mean by that? If you look at the entire CORD stack, it consists of storage, network, compute, and then you have all sorts of components which you have to build together before you can start experiencing CORD. And putting all of this software stack together requires an effort. And we have gone through that particular effort in Flex Cloud Labs, working with a couple of partners and hardware, which we have both procured from our partners as well as our own hardware. And we have put these stacks together. Today, we are allowing the access to this entire hardware and software for people to experience so that they don't have to work on putting all of this together. They can start testing the workloads directly. This lab is has a remote connectivity. It provides basically you can get access to an account and we carve out a pod for you and you can run your workloads. It has a full 1 gig connectivity completely isolated from our own internal network. So there is no conflict from our IT side. And we are constantly planning to build more pods as the time goes by. So if you go to next slide, please. We already have multiple pods which are non-code related. So we are looking at machine learning. We have telco stacks from OPNFV as well as big data. And now with open compute hardware, we have code stack which is available with this particular lab. So we have partners who are using other stacks. OPNFV, for example, is the Faros lab, which is listed on the OPNFV, and companies are using it to characterize the OPNFV stack. And the same thing we are expecting to happen for the CORD community. So with that, I'll hand it over to Sid, who will go into detail about exactly what this lab is. And we'll go through the demo with our partner as well. Thank you.
So today I would be introducing about what core community labs are, what are they trying to do in case of use case testing around our code, and how to get access to core community labs. Before starting, let me go over to Flex journey from Cord 1.0 to Cord 4.0. If I recollect, it all started in early 2016 when Dr. Guru Parulkar visited Flex campus to educate us about new initiatives in open source project for telco transformation. This was an important meeting for us because it kickstarted our journey in telco clouds and in particular Cord. It has been fantastic journey starting from first release of Cord where were doing single node deployment, and we were still on just a single cluster because this was the phase where we were trying to see what is Cord and what are the use cases which it's working on. Then we started looking around how can we scale our cluster. We moved from single node to multi-node deployment. This is the phase which we often refer to as project beginners because we started to host the first multi-node core platform for community. Then we were looking to explore more ways how can we ease process of deployment and also increase performance of our cluster. This is the phase where we got connected to Luca Prete from ONF, who helped us around in automated core deployment into our lab environment and also upgrade our fabric network from 10G to 40G. However, we were still facing a lot of deployment issues because of low bandwidth, then firewalls, Ubuntu archives. So then we started focusing toward how can we provide a lab environment which has high bandwidth connection and also easily accessible to developers. So with Core 4.0, we released Core Community Lab. So the focus here is to directly work on use cases and without worrying about the deployment. This lab is integrated with ONF Jenkins environment for AutoCore deployment. We have already onboarded test tools from our partner so that core use case can be tested. And in the next 2018, we are planning to roll more labs into this core environment based on code in a box, which could be used by developers, then OCP-based reference platform, and we look forward to onboard more use cases around core. How many of you have tried core deployment in your lab environment? Okay, if you try core deployment, there are multiple firewall issues, local repository access. So there are gaps encountered in core deployment. Let's see what happens when a new release of core is available. Developers are continuously working towards adding new features in lab. On one given night, they release core. Then the user tries the core deployment in standalone lab. However, he faces errors, which he reports back to developer, and now developer starts helping the user in his standalone deployment. So in this is the case just with one standalone lab. Just imagine a situation where all the individual lab owners are trying deployment, going back to developer. This would be a very difficult situation for developer. So let's try to categorize all the issues which are encountered in core deployment. The first is technology itself. No doubt, core has been progressing at a very fast rate. However, there are still some gaps in the project and it could be considered in early stages of development. Also, Core has a rapid release cycle with no formal training available. So with this, that as you know that there have been already 4 releases in past 18 months. So overall, there is shortage of skill set with Core. The next is the user experience. We all know that there is lack of end user community with Core, and most of the time, a user might be working on a deployment which is non-tested reference architecture. So he might face issues with the implementation and troubleshooting. The next other issue is related to regional. There are certain regions where some of these local repositories are not accessible. There are regional firewalls which will block the deployment process. And also, if you see, COD is tailored towards more developing needs of the developed countries. So many people who are in the developing countries actually don't have access to what COD is, and they don't get to know what are the capabilities of COD. The next issue is related to corporate. Most of the companies are still in early stages known as and beginners, and they don't have a big group who can support COD. Also, they won't have lab environment and might have low bandwidth for their lab environment. So overall, this leads to the delay in use case development. This is because complexity of building COD, non-availability of standard test tools with COD, and there are weak spots in certain projects, and the overall result is the use case development gets delayed. So what does these gaps lead to? These gaps leads to broken lab deployment. And what is the answer which we get? Worked fine in dev, lab problems now. So what is the solution here? The solution here is fire prevention is easier than fighting fire. So with this community lab, what we are trying to do is we are trying to drive core focus from developer to community centric. Let's look at how core has been working right now. There are different lab providers who try standalone deployment. There are test tool providers who don't have a lab, but they want to develop test cases around core. All of these are now interacting via developer for their core needs. This needs to be transformed into a community centric project. In community centric project, what will happen is the developers, can you go next? The developers, lab operators, and test tool providers will come together to stage community lab. Next. Now, this community lab would be remotely accessible to all the end user. Now, what the end user will care about is just developing use cases around code without bothering about deploying a core platform. Next. So, what are we trying to do with Core Community Lab? Here with Core Community Lab, we hope to accelerate community collaboration and adoption of Core by providing a remotely accessible community lab, which is part of a lab as a service. This will include compute network and storage devices in a Core in a box or OCP based platform. With this, we could be able to validate technology shift from telco central offices into data center, adoption of OCP and white box platform, and develop more use cases and POC around core. Collaboration will be accelerated by providing remote connection to these pod, onboarding industry standard test tools which are required for use case development, and we would provide integration services for access and core devices which goes into lab environment. The end goal here is to enable faster user learning curve to experience core benefits and capabilities. We at Flex believe in working with our partners to develop a customer driven solution. Core Lab is one of those. We work closely with ONF, who provides automation using Jenkins, platform support, and also test scenario implementation and references. At Flex, we are hosting Lab as a Service where we provide system integration, design reference platform, and remote staging lab. And Spirent is providing its industry standard Spirent Test Center virtual edition, test scenario implementation, and validation around code. So with this, what the community is getting, a community gets a lab environment which is automated via Jenkins, ONF Jenkins, and also a test tool available to directly work on use case without worrying about deploying a standalone lab. Right now, FlexPod is on Core 4.1, which is the latest release. It's based on two-rack virtual topology consisting of leaf spine, and each consists of two compute nodes connect to one of the leaf switches. The lab is connected to ONF Jenkins server for AutoGuard deployment, and the fabric right now is on 40G network. So we have been working closely with ONF and Spirent to develop use cases around our code. So let me go through what an RCOD packet walkthrough is. As you can see, when a subscriber tries in a residential code, this is the part a subscriber would be taking, going from PC to CPE, ONT, OLT, then it enters the core stack, and then will go to the CDN network. So in a lab environment, we need to simulate a similar setup. We use Spirent Test Center for that. Now, Spirent Test Center will generate frames which will emulate a subscriber traffic. This will consist of a frame consisting of S tag and C tag, which in general would be attached by the ONTs and OLT devices which are in this part. Then it will go to leaf switches where there is Q and Q cross connect. This is to just enable an outer packet to reach the core stack environment, which will then go into Q and Q lookup where the compute node would be identified, which is hosting the service gateway, where the S tag and C tag would be stripped off, which will then enter compute node again, and then the MPLS segment routing protocol, which will take into picture and route the traffic from a compute node to the another leaf switch using the overlay MPLS segment routing protocol. And this is nothing but going via the multiple leaf switches and spine switches available. So here we are there. Today I would be giving a live demo on around how to access this core environment and what are the testing which we have been doing. Can you go next? So the current testing is the data plane connectivity test, like how a packet is going from leaf one to one of the service gateway or the compute node, going back to leaf switch, then to a spine, then to a compute node, and then again back to Spirent test center. So let me get started with the live demo. Sorry, I'm having issue with Wi-Fi here. Let me show you the recorded demo which we have. So here we are showing what are the core general configurations available with showing the pod information. As you can see, core privilege shows 4 compute nodes and 4 leaf and spine switches and 3 compute nodes. And there is additional head node available. These are all the service gateways which are deployed, which are for a particular subscriber. Then we go into VSG information to get to know which compute node is hosting that subscriber gateway. We then enter the compute node, log into compute node, and then to the service gateway. Now we're trying to find out which are the VSG tags associated with the service gateway. Right now it's 404 and 101. So now we will go to the core fabric to achieve the Q and Q cross connect so that an external packet can reach the core environment. So these are the nets, all the connected devices showing in the ONOS fabric. This is where the Q and Q cross connect, the additional Spirent node gets connected into core environment. We show all of the fabric host connections available in this cluster now. And this is in relation to showing how the VLAN tags are visible in ONOS fabric. So now how to access Flex Cloud Labs as a service. There is a publicly available URL, Flex Cloud Labs, which will show all these pod information. And then you just click here, you get a VPN connection from your user client. You could be sitting in Starbucks or any Wi-Fi. And now you have access to a code environment. So with this, we have onboarded Spirent Test Center tool, which helps in testing around code. So we are trying to emulate the RCOD subscriber frame using Spirent Test Center. these are the two VLAN tags which gets added from the ONT or OLT. Here we just simulate via STC. And this is the source IP gateway, which is in general configured by the service gateway for that subscriber. The next part is to actually show the data plane functionality. We would be sending some traffic from Spire Test Center port 1, which is on leaf 1, to another side, which is the CDN side, leaf 2. So as you can see here, some packets are being sent, and we can see what is received in the RX side. We can also do some analysis around like what is the frame rate, what are the counters, is there any errors associated in this packet transfer and all. As you can see here, there were 0 packet loss, and also we can observe some counters related to the frames. So next we would be showing how the compute node observe these VLAN tag. So if we just do a TCP dump on the compute node hosting the service gateway, we can see what are the VLAN tags associated for that subscriber frame. So now the next test case which we are working on, how can we have limit on subscriber bandwidth? Using the XOS UI, we can configure download and upload speed for each of the subscriber. Right now, we are configuring 100 Mbps for the upload speed. So the next part would be, okay, we need to verify if the upload speed was configured correctly or not. So here we would be sending around, the first part would be to send around 500 Mbps of traffic, and we can observe that on the limit side, it would be still be 100 Mbps. So we are sending 50 Mbps first, and we can observe 50 Mbps on the receiver port. Now let's try to send 200 Mbps and observe what is traffic received on the RX side. So here we are sending 200 Mbps of traffic, and the receiver side is just receiving RS, which validates that we can limit the subscriber speed in case of residential cord. So as you can see, we have been working closely on all the technology sandbox, functionality testing, but there are areas to drive to have more customer-driven solution. The complexity of solution will increase, and that's where we need help from the community around having the compliance testing and vendor certification done for residential core. So this is where the community labs could be used for. Now, what can we expect next with Cloud Labs Lab as a service? We would be developing we would be having remotely accessible Box lab environment, then also OPNFP and ONAP based lab environments, Core Lab, which we already have, and we trying to introduce OCP platform here as well. And we are also working in towards setting up TIP community lab. So these all are actually service provider driven solution, and we would be providing the full rack integration and services which are required to develop new use cases. Thank you. Any questions? Any questions? Yeah, so what we are trying to do is if there are any use cases which are available on ONF and they want to work on, so the community who would be the members who would be working on that use case testing will have VPN access available for a multi-node code environment. But code in a box, which we are trying to introduce, could be used by any of these developers for bringing in new features into code. So it just based upon having interaction. And if you can define the use case which you want to collaborate with ONF, we could provide access to you. That's how it would be working. Yes, as of now, it's free of charge. Okay. Oh, as of now, we are just working on the residential code, and M code and E code are not integrated. We would be working now with ONF. We just rolled out this in October, and now we would be working closely with ONF and bringing up new stacks with this community lab. Yep. Thank you.